Hello everyone, welcome back to JDCodebase. Today is day 15 of solving LeetCode 75 study plan, and today we are going to solving a very important sliding window problem, that is the maximum number of vowels in a substring of given length. LeetCode number 1456. So let's read the problem statement. Given a string s and an integer k, return the maximum number of vowels letters in any substring of S with length k. Vowels letters in English are A, E, I, O, U, and their constant is like S dot length is up to 10 raised to power 5 and S consists of a lowercase English letter. So basically this in we are given a string S. Like here example number 1, if I say S is a string that contains the alphabets like A, B, C, triple I, D, E, F, and a number K. We need to find the maximum number of vowels present in any substring of length K. Now, this problem teaches us how to maintain a fixed size window efficiently. And here the vowels are like A, E, I, O, U, everyone knows in English alphabets. So let me show you, let me take this example A, B, C, this triple I and D, E, F. So possible strings of size 3. Why size 3? Because K is equal to 3. K is equal to 2, then size is 2. So K is the actual size of substring. Now let me build some substring ABC, BCI, CII, triple I, IID, IDE, and DEF. So these are the consecutive means ABC, then BCI, then CEII, IIII, IID, IDE, DEF. Now check how many vowels are there. One. Here also one. Here also in this two vowels. In this three vowels. In this two vowel. In this two vowel. In this one vowel. Single vowel. So here, tell me one thing. How many? What is the maximum value of vowels here? 3. Everyone knows the 3 vowels are there. So output here is the 3. The substring triple I contains 3 vowel letters. Now how to solve this? Brute force approach would check every substring separately. Like you start a for loop and in the nested for loop you run till the kth element. Like I run start a for loop, let I equal to 0, I smaller than s dot length and I plus plus, and it takes single character. Then start a nested for loop that start from the j is equal to I, j is smaller than k, and j plus plus. Now here you have to compare every character whether it is a vowel or not, then maintain the count or maximum count value. But this take the time complexity here is big of n multiply k times. Why? Because it has a nested for loop for every string. But that would means it repeat work again and again in this type of in this brute force solution. So instead we use a sliding window. Now sliding window in the last video I already tell you, first count the means take the first k character like kth value, then handle the others after that the kth value. So idea is basically first we take the window size k and count vowels in that window, and then move window one step at a time and remove the old character, add the new character, and keep updating the maximum value. So let me write the code so you can understand it easily. Let I'm making a vowels new set, and it has value A, E, I, O, and U. So these are the vowels here, A, E, I, O, U, and I just make a set. Why I use the set? Why not the array or any other things? Because set, because lookup is fast in the big of one time, means in a very fast way. Set gives us the lookup, means if I want to search whether A is present or not, E is present or not, so set gives the fastest time complexity reduces. Now first make the window of let I equal to 0, I smaller than k, I plus plus. I'm just taking the first window up to the I is equal to 0 to up to the kth length. And if vowels dot has s of I, let me make a variable let count equal to 0. And if f a vowels dot has s of I means if it is a vowel, then count plus plus. So I get the count value, mean any value like 1, 2, 3 or up to this. So this gives the vowel count in the first substring from 0 to kth length. Now let maximum count is equal to count. So I just store the maximum value here. Now slide the window. First it is a first window, then we have to slide it. For that start a for loop again. For let I equal to k. Why k? Because up to the kth value I just check all the characters, all the alphabets. Now start with the kth value. I smaller than s dot length I plus plus. And now first take out the old value is the s of I minus k, means the first value. Like the I just after this k I have to remove this 0th index, then 1 index, then 2 index up to the kth value. So for that I have to I minus k, and we have to check if vowels dot has old value, then count minus minus, means it is a vowel, then count reduce that count value because it is already removed from that substring. And now take out the new value. Let new value equal to s of I. And if vowels dot has new value, then count plus plus. So if it is a new value, then count plus plus. Now after that we have to check update the maximum count. Maximum count is equal to math dot max with the value maximum count with the value or count. So I just get the maximum count value every time, and after that we return this value, return maximum count. And let me run the code. Yes, it passed. Let me try to submit the solution. Yes, it accepted, and all the 107 test cases are passed. So basically this is a sliding window pattern. First we make a window that start from the always start from the 0 up to the kth value, and means this is a particular window from 0 to kth value. And after that we just slide the window by remove the first character and add the new character at the end, like a key, means first first in first out, means this one first insert, means then it remove then, and same for this like. And we get the value count minus minus if it is a vowel, and count plus plus if it is a vowel, else there is no need to change the count value. And every time update the maximum count value by using the math.max method. And here time complexity is the big of n because the only single for loop up to the 0 to s dot length. And space complexity also big of 1 because set size is fixed. There is no increasing or decreasing, just 5 these alphabets A, E, I, O, U. Now in this problem we learn a fixed size sliding window and how to remove and add the element efficiently in this, and how to optimize substring problem. So this is very important interview pattern, that is for day 15. If you enjoyed this video, make sure to like the video, subscribe to JDCodebase, and comment below which sliding window problem should we solve next. See you in the next video.